All right. So again, we will find the distance between 2 points, and we will find the perimeter of a polygon, specifically a triangle, by finding the distance between the vertices of the side. We want to find the length of each side of a triangle. Okay, let's move on. Slide number 2. So look at slide number 2. We are given these 2 points here. Okay, we are given these 2 points. Now I'll give you a minute to find the distance between these 2 points. So the distance is 8 units. You all get 8? Okay, Iris, can you tell us how you got 8?
So first I looked at the 2 points, and then I counted the spaces in between, and it was 8 units.
All right. So by counting, and I guess most of you did that, okay? So you count the number of spaces between these 2 points, right? Count the number of spaces between these 2 points. So we have 1, 2, 3, 4, 5, 6, 7, 8. So that would be 8 units. All right? Now, has someone found another way of finding the distance between these 2 points? Anybody else, or did we just count it? I guess we did, right? Because I did the same thing. However, okay, let's look at this. Let's write down the coordinates of this point. So the point on the left side has coordinates 1. That's 2, 2. All right, that's 2, 2. And the point on the right side has coordinates 10, 2. There was no change in y, right? The y coordinates are both equal to 2. What changes is the x. So for the first point, you have the x coordinate 2. For the second point, the x coordinate is 10. How would you get 8 from 2 and 10?
I put 10 minus 2.
Very good. Okay, so you subtract the x's. Okay, so 10 minus 2 will give you 8. Subtract the x coordinates. So this is another way of finding the distance. Either count or you subtract the x values. All right. Now you can count if you have a horizontal line like we did here. All right. Let's look at slide number 3. So this time we have these 2 points. All right. Okay. So what's the distance between these 2 points?
6 units.
6 units, right? Because we count again. 1, 2, 3, 4, 5, 6. That's equal to 6 units. Now let's use the coordinates. The coordinates of this point on top is 2, 5. Right? Your x is 2 and your y is 5. And this point here is 2,
negative 1.
negative 1. So this time it's the x coordinates that are the same. And the y, yes. So what do we do with the y?
5, subtract 5 from negative 1.
Okay, so we do 5 minus negative 1. Now remember, if you have 2 negatives, it turns into positive. Yeah, so 5 plus 1 is equal to 6. Okay, so this time we subtract the y coordinates. So if you have a horizontal line, you subtract the x coordinates. If you have a vertical line, you subtract the y coordinates, other than counting. Okay? Counting is okay. But I want to establish this because we will, as I was saying, derive the formula for finding the distance between 2 points. All right? Now, let's look at the next one. So slide number 2 is horizontal. Slide number 3 is vertical. Slide number 4, it's neither horizontal nor vertical, right? It's diagonal from each other. All right. Do you have any idea on how we can find the distance between these two points? This Desmos is under week 14, day 1. So go to your Canvas, week 14, day 1. Okay, if you have a diagonal, what you can do, because we know how to find horizontal and vertical, right? So what you can do is draw a horizontal and a vertical. So in essence, we are drawing a right triangle through these 2 points, okay? So see, we'll draw a vertical line here, and we can count this to find that distance, right? And then we have this horizontal distance as well. So basically, we can draw a right triangle, okay? This horizontal distance, like we did in slide number 2, we can count. So that's 1, 2, 3, 4, 5, 6. This is 6 units. And the vertical distance would be 1, 2, 3, 4, 5. That is equal to 5 units. All right. Now you have here a right triangle, right? Now we have discussed right triangle before. If you have a right triangle and you are missing a side, what theorem would you use to find that missing side? Starts with a P. Starts with a P. You know this. Second letter is Y. So PY.
Pythagorean.
Yes, it's the
Oh.
Pythagorean theorem. Do you remember what the Pythagorean theorem is?
A squared plus B squared equals C squared.
Very good. It's A squared plus B squared equals C squared. I'll just flip it around, okay? So I'll write down C squared is equal to A squared plus B squared. Okay? Now C represents the hypotenuse of the triangle. In other words, this is the longest side. Okay? It's the side opposite the 90-degree angle. So in this triangle, the distance between these 2 points is basically your hypotenuse. That's your C. Okay? And the other 2 are the legs. So let's say A is equal to 6 and B is equal to 5. Okay? So let's solve for C, for the distance. We get C squared equals A is 6. So we plug in 6 for A. And then we plug in 5 for B. Right? Now let's evaluate. What is 6 squared?
36,
6. And what is 5 squared?
25,
25. Okay, so we get C squared equals 36 plus 25 is 'you can use the calculator on top. 61. So your C squared is equal to 61. We do not want C squared. We want C. So what do we do to find C? What's the opposite of squared?
Square.
Square root. Okay, so your C would be equal to the square root of 61. Now 61 is not a perfect square, right? So if the problem does not tell you to round it off, you can leave your answer as a radical. So the distance between these 2 points is square root of 61. Okay, so we just applied a theorem that we have used before, the Pythagorean theorem. You can use this if you have points on the grid. Okay, because you
wait.
can simply count. Yes?
I didn't quite hear you at the last part. So you said if you can't round it, what should you do?
If it's not a perfect square, right, you can leave it as a radical.
Okay.
You can leave your answer as square root of 61.
Okay.
However, if you get, say, for example, square root of 25, you do not leave it as square root of 25. Because we know that square root of 25 is equal to 5, right? So if you can get the square root of the number, get the square root. If not, if you will be getting a decimal, keep it as a radical. Okay, unless it's specified that you need to round your answer. And we'll have examples of that later. Any question here? All right, so move on to slide number 5. If you finished copying this, go to slide number 5 and do the same thing. Let me give you, what, 2 minutes? 2 minutes for slide number 5. So I'm seeing that most of you did your triangle below the line. If you did it above the line, that is okay too. All right. Now let's count. So this would be 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so that's 9 units. Let that be our A. And then this is 1, 2, 3, 4, 5. That is our B. It's 5 units. So we're solving for C. Okay, C being the hypotenuse. So again, your Pythagorean theorem is C squared equals A squared plus B squared. All right? So C squared is equal to, our A is 9. Check your work class. 9 squared plus your B is 5. So plus 5 squared. All right? Now what is 9 squared? 9 squared is 81. Okay? 5 squared is 25. Right? So your C squared will be equal to 81 plus 25, which is 106. Which gives us a C value equal to the square root of 106. Okay, so any questions here? Right, it's just a straightforward application of the Pythagorean theorem. Now from here, I want to derive the distance formula, because if you do not have a grid like this one, it's hard to count. Okay, and if you cannot, if you don't have the grid, sometimes it's better to use the distance formula. Okay, so remember your horizontal distance, we're subtracting the x coordinates, right? So this is basically x minus x. Okay, let's name it x2 and x1 to differentiate them. And then your vertical distance is the difference in y, right? We're subtracting the y value. So you have y2 minus y1. And it would translate to here. So the horizontal distance is x sub 2 minus x sub 1, right? And the vertical distance is y sub 2 minus y sub 1. And we learned this from slides 2 and 3, right? We're looking for the distance between these 2 points. Now let's call the distance between the 2 points B. B for distance. Okay, so the hypotenuse for this right triangle is B. our Pythagorean theorem, okay, is c squared is equal to a squared plus b squared. Okay? So if you do not have a grid, this is what you use. Now your c is the hypotenuse, and the hypotenuse here is b. So instead of using letter c, we will use letter d. So that's b squared. Okay? Remember, this is your a, and this is your b. So it's equal to a squared. Your a is x sub 2 minus x sub 1. So this a here, we'll replace it by x sub 2 minus x sub 1. So that's your a squared. All right? And then our b is y sub 2 minus y sub 1. So we will replace the b by y sub 2 minus y sub 1. Okay, so you have your c squared equals a squared plus b squared. And then we get the square root of both sides because we just want the d. We do not want the d squared. We just want the d. So the distance will get the square root like we did before. Square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. This is your distance formula. Okay? So you have the square root, and then you have your two sets of parentheses. The first set of parentheses is for your x. And the second set of parentheses is for your y. Okay? X is the first coordinate, and y is the second coordinate of the point. All right? Okay, can we move on? Okay, let us look at slide number 7. Ready, class? Slide 7. All right. So see, for slide 7, we can find the distance between the points without using the grid. All right? But here's what I want us to do. We will use the distance formula first, okay? And then we will use the grid. And you will notice that you will get basically the same answer. You will get the same, exactly the same answer, okay? So let's use the distance formula. Because that's our lesson, distance formula, right? Okay, we are given 2 points, negative 2, 3, and 4, negative 1. Okay, we've got these 2 points here. Now, the first coordinate, we can say that this first point here is your x sub 1, y sub 1, right? And the second point is your x sub 2, y sub 2. That means your x sub 1 is negative 2, your y sub 1 is 3, your x sub 2 is 4, and your y sub 2 is negative 1. All right? And then what we will do is we'll plug these numbers into your distance formula. Now let me set up the distance formula here. So distance is equal to the square root of this, the first parenthesis is for your x. All right? The second parenthesis is for your y. So x squared plus y squared. And let's plug in the values. So for your x values, you have x sub 2 minus x sub 1. So x sub 2 is 4. We're plugging in, huh? X sub 2 is 4 minus x sub 1 is negative 2. All right? And then for the other parentheses, we'll put in the y values. So you get negative 1 and then 3. right? Let's evaluate this. We're doing this step by step. What is 4 minus negative 2? So let's work.
4 plus 2.
6.
It becomes 4 plus 2. So you have 6. So that's 6 squared. Okay, 4 minus negative 2 becomes 4 plus 2, which is equal to 6. Now, if the base is positive, it's okay not to put it inside the parentheses. Okay, so since 6 is positive, I'll just write it down as 6, no parentheses. Okay, the other part for the y, you have negative 1 minus 3. What's negative 1 minus 3?
2.
Negative 4.
Negative 4. Okay, it's negative 4. So you have negative 4 squared. If you're not sure, class, of your answer, use the calculator. Okay? Because sometimes the mistake is not because you do not know how to do it, but you messed up with how to add or subtract the numbers. Okay? All right, so you have b equals the square root of 6 squared is what? So we're now evaluating what is 6 squared. 6 squared means 6 times 6, which is
36.
36. Yes, positive. Plus, what about negative 4 squared? So I put negative 4 in parentheses because it's negative. So what's negative 4 squared?
Negative 16.
Will it be negative 16?
Wait, 6.
Positive 16, right? Because negative 4 squared is the same as negative 4 times negative 4. And we know that if you multiply two negatives, it becomes positive. So negative 4 squared is positive 16. So when you square, you can ignore the sign, all right? Because it would always come up positive, all right? What is 36 plus 16? 36 plus 16 is
52.
52.
2. So the distance between these 2 points is square root of 52. And it's right down here. So click on square root of 52 and you will get the feedback. We have those 3 planes. Okay? Now, supposing I give you the grid, because in the quiz, even in your SAT, sometimes all that's given is this, the pairs of points. Okay, so if you have a grid, and I would give you a grid like this for the quiz that you can use. What I need you to do is to plot the points correctly, because if you incorrectly plotted the points, you will miscount. Okay, and it would affect your answer. So let's plot these 2 points. The first point is negative 2, positive 3. Remember, the first number is your x. So negative 2, positive 3 is right at that position. And the second point is positive 4, negative 1. So x is positive 4, y is negative 1. We want to find the distance between these 2 points. All right? So we'll draw our right triangle. Just like we did previously, we have the right triangle. Okay, this is your C. This distance is how many units? You can count. 1, 2, 3, 4, 5, 6. So that's 6 units, right? And this vertical distance would be 1, 2, 3, 4. That is 4 units. So one side is 4, the other side is 6. So we can now find C squared, right? C squared is equal to the square, the sum of the squares of the sides. So you have 6 squared plus 4 squared. Okay, 6 squared is 36. 4 squared is 16. So notice that you have 36 and 16 here as well. 36 and 16, right? So c squared is equal to 52. 36 plus 16 is 52. Therefore, c would be square root of 52. Now, there are pros and cons to using either the Pythagorean theorem or the distance formula. You just have to be very careful, okay? Whenever you use either one of them. Question? All right. So some of you have started with slide number 8. Go ahead and go to slide number 8 and get started. You may use the distance formula or the Pythagorean theorem. You might want to do both, to use both, so that you can check your answer. And I will show you something interesting.
I'm sure I won't. Just have a chance that someone does come. I'm sure. Yeah. 3 weeks.
Oh, something you-
I did.
Okay, yeah.
No one's gonna come, so. Thanks, Con.
No problem. All right. So we are given the points -4, -2, and 2, -5. Okay. So we said that we will make the first point given as your x1, y1, and the second point as your x sub 2, y sub 2. Okay? And then I set up your distance formula. The first parenthesis is your x, the second parenthesis is your y. Be careful when you plug in the x and the y coordinate. You include the sign. So you have your x2 minus x1. x2 is positive 2. All right? x1 is -4. So you include that negative. All right? Now, the second parenthesis is your y. y2 is -5. y1 is -2. I see some of you missing the signs. All right? Any question here? So make sure that you have the signs correct. So, that b is equal to the square root of, now what is 2 minus -4? That becomes 2 plus 4, right? 6. So that's 6 squared. What is -5 minus -2? Okay, let's try the calculator. I don't want you to be guessing. -5, you can use that minus sign. -5 minus -2. It will give you -3, okay? So this one is -3 squared. All right? -5 minus -2 is -3. So we get here 6 squared is 36 plus -3 squared, that will still become positive. It's equal to +9, right? So therefore, the distance would be equal to the square root of 45. Okay? Now, I want to call your attention here, class. Say you don't put in the subscript. Where can I write this down? I'll write it down here. So you have -4, -4, -2, and then 2, -5. So let's just say that this is x, y, x, y. All right, just type in x, y, x, y. Don't put in the subscript, that's okay. So the distance, this is your x, right? And this is your y. So look here. First parenthesis is your x. It doesn't matter whether you write down -4 first or you write down 2 first. It really doesn't matter. As long as you're putting in both x's into the first parenthesis. So let's see, you'll have, say, you use -4 and then 2. Those are your x values. Now, for the second parenthesis, we're putting in the y. So your y's are -2 and -5. Okay? So this time, let's do -5 and then -2 because those are my y values. I don't care how I write them up. -5, -2. As long as I put in the y. So see what happens. -4 minus 2 is -6. Okay? And then -5 minus -2 is -3. All right? If you don't believe me, use the calculator. So -4 minus 2 is -6. -5 minus -2 is -3. Now, -6 squared is +36. -3 squared is +9. So we get the same thing, right? That's equal to square root of 45. So what I'm trying to say here is, as long as you put the x's together, be careful with the sign and put the y's together for the second parenthesis. Don't forget the sign. Use your calculator if you're not so sure about how to add, how to subtract integers, okay? And you'll get the right answer every single time. All right? Any question? Okay, so I just have 3 minutes for the next one, but let me just get started here. All right, so here you are given a triangle. We'll fill this table up, all right? So since it's in the grid, we can just use the Pythagorean theorem. So the first thing that we want is to find FG. This is your FG, okay? We will draw a right triangle through FG, just like we did earlier, okay? So forget this triangle below, and let's focus on the right triangle above, okay? This right triangle here. Now let's count. This is 1, 2, 3, 4, 5, 6, 7. And this is 1, 2, 3, 4, 5, 6. All right, so FG is the hypotenuse. Okay, so hypotenuse is FG, so FG squared is equal to the square of the legs, right? So it's equal to 7 squared. We're just going back to our Pythagorean theorem, plus 6 squared. So 7 squared is 49. 6 squared is 36. So 49 plus 36 is 85, right? Now, look at the instruction. It says round to the nearest 10. which means that we need to evaluate this. So FG squared is 85, therefore FG is equal to the square root of 85, which is approximately, let's get our calculator, square root of 85, which is 9.2. All right? So your FG is 9.2. So type in 9.2 here. Okay, and you will get that smiley face with sunglasses. Okay, so every time you got that, it means that your answer is correct. Question? So we're just putting everything together, all right? Okay, for this one, for EG or GE. So for GE, oh my goodness. Yeah. So please complete this and then fill that out. And then you know your perimeter is, you just have to add these three. Okay, whatever values you got. So on Friday, when we meet on Friday, we'll do slides 9 and 10 together, but so that you can check your work. But make sure that you do that you do it on your own. All right? Okay, so I'll
I'm
see
Sam.
you. Bye. I'll see you again on Friday. Bye.